actually ended off here, right? Do you all manage to finish your question?
He's selling his money.
You all manage to finish this? Okay, let's just check answers then. Okay, for me, part 1, your answer should be negative 7 and 9. Then part 2 should be negative 3, 0. Okay, I think it's similar to how our matrices work, so I think it probably shouldn't be too difficult for you. Right, then after that, B part 1, answer x is 13, y is negative 10. Okay, then after that, for B part 2, we have x negative 1 and y equals to 2. Right? Now let's look at example 13.
Wait,
Yeah?
x equals negative 1 and y equals to negative 10.
Yes. Okay. Now let's look at example 13. Yeah. We have given this vectors over here, P, Q, and R. Okay, and then we want to draw in the grid, okay, for these 4 vectors over here. Right? The drawing it might overlap because the grid given you over here is rather small. Okay. So in order to make sure that those people who are OCD doesn't have very untidy notes. Okay, let's just start off one together first.
I don't get it. P plus Q plus Q.
Yeah, but I want to verify that. Yeah. Okay. I'm trying to do in this exercise to verify that P plus Q is equals to Q plus P, and then after that P plus Q, then plus R, and versus P. Q plus R first, then plus P. They are actually the same, which is my question over here. Okay. I know that we are fast enough to know that they are actually equal, but let's just go through this exercise. Okay. So first one, we want to draw P plus Q. Okay. So P is like that and Q is like that. Okay. So I'll draw my P over here.
So do we not add them together first?
Huh?
Do we not add them together first? We draw
No. Okay, I want it to be drawn. Okay, I want you to draw the P plus Q. I mean, you can add them together lah.
Then it will be single line.
Yeah. I didn't think about that. Never mind. Okay, let's just draw it. Sorry. Sometimes I'm very focused on one thing. I forget about other things. Okay, so P is actually drawn in this manner. Then after that, Q is actually 6 2, yeah. So that would be like that. Yes, please. Okay, and then after that, Q. So therefore, P plus Q will actually be a horizontal line in this manner. Right? This will be P plus Q. What's wrong? Your phone? One digit off. When you go, don't try with Gerald. Okay, then after let's skip part 2 first. Okay, let's look at part 3. We have P plus Q first, then plus R. So we have over here P plus Q. Okay, and then after plus R, we need to say that from P plus Q, this horizontal line, we continue from this end over here to have a vertical line, okay, of 5 or 0, rather 0, 5. So R will be actually this vector here.
Oh no.
Okay, and hence the final resultant for part 3 would actually look like that.
We have a red pen.
draw Q plus P. So I'm trying to maximize the space over here. That's why I'm doing this over here. Okay. I know that you are highly competent to do this on your own. So Q plus P, we have this direction, this line over here, and then P is this one. So let's just start from here. 3, 4, 5, 6. So Q will be this way. And then after that, P is downwards. So really at this stage now, we see that Q plus P and P plus R, Q plus P and P plus Q is actually the same. Okay, so yes, these two vectors are the same. Yes, same type.
But if I have P plus Q, right, can you just express P plus Q as just one line?
After we draw what?
Like after you find the development vector of P plus Q, right? When we need to do the P plus Q plus R, we do it separately. We have to draw the entire P plus Q and then the development vector.
I don't think. Okay, so you're asking me whether you still need to draw the P plus Q first. If you're asked to draw P plus Q plus R, is it? I believe no. Okay, this is just an exercise for us to actually draw these conclusions. Yeah. So in test exam wise, usually not necessary. You just have to draw the resultant vector. Okay, then after now part 4, we want to draw P plus Q plus R first. Okay, so let's draw Q plus R first. Okay, so for Q, let's start from this corner here. Okay. Okay, so Q will be like that, and then after that plus R, so going outwards by 5, 3, 4, 5. Okay, so Q plus R would actually be this. Then after that, we need to plus P. Okay, so P actually came first before Q plus R, but we have seen that from part 1 itself, okay, P plus Q and Q plus P are the same. So I could actually draw Q plus R followed by P, right? And then we will be able to get this vector. It will be P plus Q plus R. So therefore, we do see that they are actually equal. Yes.
When do you put 2 arrows and 3 arrows?
When do we put 2 arrows and 3 arrows? Have you been taught 3 arrows before?
Then you put 3 arrows.
Where got 3 arrows? Oh,
This is plus R.
why did I do that?
Can you do that? Because we put 2 arrows for P
I
plus,
think should be
P
double
plus
arrow.
Q already.
Should be double arrow because it's still a result. It's just the resultant being 2 arrows.
So it's only 1 and 2.
Yeah, when it.
So, but will it be very confusing because you already have one resultant form?
Yeah,
Hey,
it's
resultant
vector.
vector.
Can I go and think about it? Yeah. I need to go and look at whether how exams actually set this question. Okay.
I like to say resultant.
Yes. Yes. Seem very disoriented. Yeah.
the table. I have not yet touched to my worksheet. Never mind, you can use your imagination to feel that gap. Now I realize another student with a weird laughter.
No, she tried to copy Hui Min.
Yeah, I have never. Everybody was silent while she laughed.
Yeah, I know, right? Everyone was so quiet eh.
I think my laughter is funny.
It's recorded in the video.
Oh yeah.
You become a lead for
So what the fuck if I never
There was
really
some time
get it out?
Okay, anyway, so homework today did you yeah, I will make sure you all submit to me on 9. What time are you dismissed at 9 or 9 April? 9 a.m.
So you talk about
As in dismissed from lessons, 9 a.m. Choir, what time are you dismissed? What times are choir members dismissed on Monday? Oh yeah, because your gel, your hair, and your makeup, right?
the first time I started to leave.
Would it be on Wednesday? Wednesday, would that be okay?
No, Monday. He just wake up. I need plastic surgery.
Okay, can we continue please? Let's get scalar multiple. Okay, so I mentioned already that for parallel vectors, right? Okay, they are either same or opposite direction. Okay, we would also look. We also see from here in this section. Okay, that for non-zero and parallel vectors, okay, they can be scalar multiples of one another. Okay, meaning to say that if A and B are actually parallel, okay, provided that they are also non-zero, I can express A as a scalar multiple, for example K, times the vector B, right? So K is actually a scalar value, right? B is a vector value, okay? So if I say that A and B are any two vectors and A is equals to KB, so if I were to say that there is this equation over here, I cannot immediately conclude that the two vectors are actually parallel. Okay, I can either conclude any of these three possibilities. First is that they could be parallel. Second could be that they are zero vectors. Okay, so then after that K could also be zero. So unless it is very clear that neither the two vectors are zero and also neither is it that the value K is zero, then surely we can conclude that they are parallel. You understand? Okay. So let's look at this this consideration over here, whereby A is actually 6, 12 and B is 3, 6. Then C is negative 2, negative 4. Okay, we see that 6, 12, right, it can be actually 2 times of 3, 6 and that is equals to 2B. And then after also A can be expressed as a scalar multiple of C. Okay, if I were to express it in this manner. So since all of these three vectors given over here, as long as the value of the scalar value, they are all not zero, we can see that A, B and C are going to be parallel to one another. Okay, so moreover, if we look at the magnitude of things, okay, if I look at the magnitude of A itself, that will be 6 squared plus 12 squared. And then we see that there is square root of 180. I could actually do my simplification of the surds. So since we are already familiar with that, that will actually be 6 square root 5. Okay, because 180 is 36 times 5. Right? So similarly, for B and C, we can find its magnitude. And that would give us its. Okay.
Where?
Coba dah coba dah.
Where's that? This?
Where was it?
Oh, it's not under my table, it's under his. Sorry.
I told you.
You don't need to cry.
Yeah. Go. Yeah, that's so true.
I don't throw too hard, okay?
So in this case, okay, looking at the magnitude of A to be 6 square root 5, right? Okay, 6 square root 5 is actually 2 times of 3 square root 5. Okay, and then 3 square root 5, we know that that is actually modulus of E. So we actually know that, okay, we can definitely write it in this manner. In this one is also consistent with our modulus. Alright? Likewise, okay, for modulus of A, that would actually be 3 times of C. Okay. Although over here, the relation between A and C is actually a negative 3 over here. Okay. So we know that modulus of modulus of negative 3 is actually equals to 3. So we will still be able to have a same conclusion that if there are two vectors, they are scalar multiples of one another. Okay, magnitude wise, I could actually separate them out if they are multiplying each other. Okay, so this is a similar conclusion to our understanding of modulus. Okay. Parallel. So part A, are they parallel? What do you think? Okay, so is part A, are these two vectors parallel?
No.
No, right? Okay, so how do we actually go about explaining it? Okay, we can actually say that 6, 8, the vector 6, 8 is actually equals to 2 times of 3, 4. Okay, so there is no relation to 2, 4 itself. So since 6, 8 is not a scalar multiple of 2, 4, the vectors are not parallel. For negative 8, 16. So since the vector 24, negative 48 is a scalar multiple of negative 8, 16, the vectors are parallel. Negative 6 and 20, negative 4. Are they? Yes. Then how do we determine the scalar multiple? What would it be? 1.5. Okay. So we can see that 30 if I divide by 2 times, sorry, is it 1.5? Oh yeah. Divide by 3 over 2, then we will be able to get 20 and negative. Right? So same thing, same explanation.
I thought Mr. Tan would take. That was another.
Just stop.
Okay, let's look at the next one, example 15. Okay, given that 4, negative 3, and 12 p are parallel vectors, we want to find the value of p. Okay, so we can determine what is the scalar multiple in this case just by looking at the x component. Okay, so the scalar multiple for this will actually be 3, whereby 12p is equal to 3 times of 4, negative 3. Okay, so since they are parallel, and they are also non-zero vectors. Okay, so therefore p will be equals to 3 times of negative 3. P will have to be equals to negative 9. So you need to determine what is the scalar multiple first, then after that form the equation and get the value of p. Okay. Next, if u is equals to 1, 2, v is this, w is this, find a single column vector to represent the following. Okay, could you start doing this? I believe it is something very manageable. Right? And then example 17, there will be 1.5 and 3 for x and y respectively.
Yeah. Oh, really?
Okay, I have given out the last set to this entire chapter, last set of notes for this entire chapter. Okay, you can staple everything together. Okay, next, 5.5 actually is just a very simple and short one-page thing. Okay, so 5.5 is about expression of a vector in terms of two other vectors. Okay, so if I were to have a vector p and q in this manner, okay, I want to express this vector in terms of p and q. Right? What do you think? Oh, sorry. Okay, what do you think AB could be expressed as?
Negative AB.
Negative AB. What A, what B? Say what? I mean, expressed in terms of P and Q.
Oh.
Yeah. So, how do I express AB in terms of P and Q?
Q plus negative P.
Q plus negative P. You sure? Q plus negative P.
No. P plus P. P minus Q.
We can do scalar multiples. Okay, we have learned scalar multiples in class.
P minus Q.
Q minus 2P. Sure?
2P minus
Q
Q.
minus 2P. Q will be like that, then minus away 2P.
No, it's
But it starts from A to B
so it's 2P minus Q.
2P P minus Q, right? Yeah.
What?
So from A itself, okay,
No, because
2P will actually refer to having this is 1P.
First,
Then after that, second P will actually be like that, right? So this is 1P, second P, and then after that, going to P itself, we require a negative Q, right? Okay. Although there was no requirement to draw, okay, this is just a drawing to get the understanding, right? So AB is actually 2P minus Q. Okay. What I'm trying to say in this section over here is that for any vector, okay, that you're given, you can express it uniquely in terms of two other non-zero, non-parallel, coplanar vectors. Okay, so it seems that there's a lot of words. Okay, basically it can be expressed as two other vectors. Okay, there can be many different scalar multiples for that particular vector. Okay, and then after that, the addition of it or the subtraction of it will give you the vector AB. And that combination itself is something unique. Okay, so coplanar vectors coplanar means that it is on the same plane, not your aeroplane, but on the same surface. Okay. You know, some people may really think that planes are aeroplanes.
So is the answer 2P minus Q?
Huh?
2P minus Q.
Yeah, 2P minus Q. Okay. So that's 5.5, that's done.
Yeah.
There's really nothing much. Okay. We are going to the important parts already. Where is Okay, we're going to look at position vectors. Okay, so we are building up all our concepts, alright, all for 5.6 and 5.7. Okay, so 5.6 position vector, what exactly is a position vector? Okay, earlier on I mentioned that whenever I drew my vectors itself and giving you the x-axis and y-axis, it is not for us to actually, it's just for us to actually determine the spacing, how many units there is. Okay, but actually if we are given a certain coordinate, right, we can also very easily tell what is the position vector of that point relative to O. Okay, so for position vector, it is about the position, or rather it is about the vector itself, okay, of that particular point relative to the origin O. So it must be relative to a fixed starting point. Okay, so that's the whole idea about position vector. Whereas the rest that we are looking at, we are just looking at empty space with a grid, and then after that looking at the x and y component and giving us the vector itself. Whereas for position vector, there is this relativeness, alright, if there's such a word, okay, to the point O itself. Alright? So, okay, consider a certain point. Okay, can you give me any point?
2, 3.
2, 3. Okay, so let's look at the point 2, 3. That will actually be here. So if I were to look at the point 2, 3 relative to O itself, we are looking at this vector. Okay, so we would see that the vector itself, if I express it as a column vector, okay, that will be 2, 3. So for a position vector, okay, because it's relative to O, we tend to write it as OP. So the point P has a coordinate 2, 3, but to express it as a vector, we will write OP with an arrow on top, okay, and equals to 2, 3. Right? So they are the similar way to how our coordinates was being presented. Alright, just that this is somewhat like a matrix form, it's a column matrix. Okay, so if I were to let Q to be 5, 3, for instance, 5, 3 that will be here. Okay, we would then be able to tell that the vector OQ, what would it be? What would the vector OQ be?
5, 3.
5, 3 also, right?
Then how do you know the direction?
Okay, the direction is told to us in this location, right? So OP will refer to this, and then OQ will refer to this. O is the start one. Based on this notation, we agree upon that this refers to start, and this refers to N. So the direction must actually be this way.
Then how to have?
How to have what? Okay, so therefore, if I want to find out what is PQ, okay, earlier on when we look at addition and subtraction, we know that I can add two vectors so long as the middle part, okay, they are of the same point. Okay, I can add them out very easily by taking the first point and the last point to give us PQ. So I can see PQ as PO plus OQ. Agree? That was what I meant by the middle part. Okay, must be the same, and then after that the resultant will just be the start and the end. Right? So PO earlier on when we look at negative, okay, vectors, PO is the same as negative OP. Okay, and negative OP, we know that OP is actually 2, 3, so that's negative 2, 3, and then OQ that will be 5, 3. So this sum will give us 3, negative 2. Okay, sorry. Am I doing right? Oh, sorry. Wait, 2, 3 and 5. Okay, now OQ is 5, 3. And that will give us 3, 0. Okay. So 3, 0, it is the same as per how our drawing is done. Okay, whereby PQ, if I look at this drawing, PQ will refer to this one here. Okay, and that is 3, 0. Okay, what we can see from here is that PQ can be regarded as the movement from P to Q, and we call PQ as a translation. We call this as a translation. Okay, from P to Q, whereby we move P all the way to Q over here. Okay, so PQ itself is a translation vector which describes the movement of P to Q. Okay, although in our syllabus we don't look at translation and all that, okay, but I think it's necessary for us to be familiar with this term translation. Okay, translation simply means moving. To translate from one point to another point. Okay, and to translate this movement, okay, we use a vector to describe it. Yes.
Then shouldn't the resultant vector be OQ?
OQ. What do you mean by resultant vector? Resultant of what?
Is there a resultant vector?
What are you talking about? I don't understand. Are you referring to what I'm talking about translation? What is your question? Okay, let's move on, yeah? Okay, example 19, you want to write down the position vector of the points P and Q, then express P2 as a column vector. Okay, could you do that? Part A. We will do part A first. Yes. Yeah. Whenever you're given coordinates, you're always taking with reference to O. Alright? I already got your answer to your question. What was the question? I'm not trying to. Maybe I should go down. I'm not trying to do a result. These two vectors. I'm not trying to. I'm trying to just emphasize that it's using revolution. Yeah.
So it's not on this one.
No.
Then it's not the
resultant of these two vectors you have to go on. The resultant of these two vectors.
So it's always from O.
I'm just
But why not?
This one you cannot draw.
But this is just to find out.
Yeah. I am not using this as to show the result. Yeah, I'm just using it to show this PQ and exercise. That's all I'm saying.
Draw triangle when this one is a triangle. That is a triangle. So you must yeah. But in this case we are not finding without the point, we are just finding the direction.
Are you done? I hope that you're able to get the vector to be negative 9, 9. Right? Okay, sorry about the confusion earlier. When I was drawing this PQ, I was not trying to draw a resultant vector of these two vectors over here. I was just trying to point out how PQ looks like. Okay, so I probably shouldn't use double arrow. Okay, if you have taken double arrow to avoid confusion later on when you make your notes, right? It should just be a single arrow. Okay, I'm just trying to indicate how PQ looks like. I am not trying to do a resultant vector of these two. The resultant vector of these two would by right, okay, be starting from O all the way to somewhere, I don't know where. Okay, if you completed the parallelogram. I cannot continue because the green is here. You understand what I'm saying? This is not a resultant of this two. Okay? But I can find out how PQ is like as a combination, as a sum of OP and OQ, which we have seen over here. Okay? There is actually a negative OP plus a OP. You understand what I'm saying? Okay? So part A, you should have gotten negative 9, 9. I'll skip the writing, the working over here. Okay, let's look at part B. So part B itself says that a point A is being translated by a vector over to B. Okay, over to the point B. We want to find out what is the coordinates of B. Right? Very simply, okay, even if you don't understand translation, you need to know the basics of how addition and subtraction works, okay, based on the notation. So I could see OB as a sum of OA plus AB. Do you all agree? Okay, so I know what is OA because I am given the coordinates 6, negative 7. And then AB, that is clearly given to me to be negative 4, 5. Okay, so therefore, the answer would be 2, negative 2. Just that the question wants the coordinates of B. So therefore, it should be 2, negative 2 written in coordinates form. Okay.
这样看有 plus then you can
Otherwise, what would you recommend?
Minus.
Minus? Why would you minus them together? Take note that subtraction, okay, doesn't work by taking the first and the last point. It is only by addition, whereby the center point is the same, then we can have the resultant to be O and B.
Oh.
Okay? So that's why I can only do addition. Okay, very often I will employ addition rather than subtraction. even if you don't understand what translation means, okay, you just need to be very confident of how vector addition works and know what the contraction was. Okay. Now let's look at example 14. The position vector of point A is given to be 2, 5. Okay. This means that OA is equals to 2, 5. Okay. And then AB is given to be negative 3, 4. Part A, we want to find out what is the magnitude of AB. So we have done many magnitude questions already. You should get 5 units. Okay. For part B, we want to find the coordinates of B. How do you think we should find the coordinates of B? What should we do to find it? We will find OB. Okay. So OB, that will be equals to OA plus AB. So therefore, the point B is negative 1 diagonal. Now for part C, given that CD is parallel to BA and CD is given to be this, we want to find the value of K. So since they are parallel, okay, and then of course the vectors are non-zero, I will be able to express these two vectors as a scalar multiple of each other. Okay, so CD is actually K 13.6. That will be a scalar multiple. Let me just use the scalar M because K is already being used. Okay, you can use any letter in fact. Right? M times of negative 3, 4. Right? The very end that I want to achieve is to find out the value of K. But you will find that K is actually equals to M times negative 3. I'm hindered by the value M. Okay, so I need to first find out what is the value M. And that can be found by looking at the Y components. So 13.6 is equals to 4M. MM will be equals to 3.4. So therefore, K will be 3.4 times of negative 3. That will give us negative 10.2.
So BA is equal to AB. Or I just put a negative in front.
Oh, I'm sorry. Let me change this. BA. So it should be negative M, right?
So can you just change it inside?
So like you just flip the inside.
Yeah.
So you don't
Or
need.
you can fit. As in,
Not flip lah.
now you put
flip
negative.
The sign.
No, like change the 3, then 3 negative 4.
Yeah.
Can but still just step on it, right? It will be up to your preference. They mean the same. Okay? Let's look at example 15. Did I use the example 15? Oh, sorry. Oh, I think I didn't put my numbers. Sorry. It's not in continuous. I had 19 earlier, so it should have read. Yeah. Oh, sorry.
Oh.
Yeah, earlier one I didn't go through the example. Page 16.
Negative M would be.
Here it should be actually
times 4 is what?
wait, negative 4M plus
1.2, right? 1.2 plus negative 9. You got a lot of negatives.
wait, negative 4M equals to 13.6, correct, right? n is equal to negative 3.4, correct?
Okay, like k will be negative n.
K will be equals to
Negative. So let's say the something I did is
negative 3.4 times negative 3. So that will still be negative 10.2,
Oh, it's negative.
right?
no, because you never simplify the start, so m is negative. But it's negative m, negative 3 is 3. Negative 3 times negative 3. But m is negative 2 also. So 3 times negative 2.
Right.
Negative.
That's just simplify the start. Using what?
You know that we have
K is equal to negative.
Yeah, sorry. Simplify the start.
actually like a minus n. You don't have you don't have minus n.
Must. Because
N can be just minus itself.
it is BA, this is AB. So you must have the negative. Yeah. The M cannot take care of itself. Cannot take it out. It just I think it just coincidence.
You just split the AB to be at the start.
Yeah. Okay, I think at the start, yes, I will give change AB to BA first. Okay. If you want to put a negative sign, you must have to put a negative sign. You cannot say that the M will take care of itself. Okay, because it must be consistent with what the question is saying, that CD is parallel to BA. BA is a negative of this vector. Yeah. It is not. The direction must be considered. Yeah. Can you let me go and think? Yeah. No. Not yet. Because if you don't put the negative sign, why would the M actually?
The negative is not for m. It's for AB to be out.
Because
M does not be yeah,
Can you let me?
one of AB, right? That's the bottom thing, right?
Okay, let's look at example 15.
Just if you multiply the minus
Okay, O is the origin, P is the point 3, 1, and Q is the point negative 2, 4. Given that the vector OR is given as this, we want to find the coordinates of R. Okay, so that's a simple calculation. Okay, OP minus OQ, so OP is actually 3, 1. OQ will be negative 2, 4. So therefore, the coordinates of R 25, negative 3. And then for part B, we are given that OS is equals to OP plus 2OQ. So therefore, OS is given with the coordinates x, y. We would then be able to find that x is negative 1, y is equal to 3. CA is parallel to BA. Okay, I can also say that CD is parallel to BA. I can also say that CD is parallel to AB. Am I right to say that? Is CD parallel to AB?
Yes.
Okay, why can we say that? Because in vectors we know that the idea of parallel means that it can be same direction
Or different.
or else different, not different, opposite direction.
The magnitude.
Okay, so either of this case, right, we can still say that the vectors are parallel. So therefore, at the beginning, okay, when I express my equation K13.6 to be actually a scalar multiple of negative 3, 4, okay, if I put a negative sign outside to address the consistency with the question to be of the same direction, I will get negative 10.2. But even if I don't, okay, I will still be able to get K equals to negative 10.2. And that is because parallel vectors is either same direction or opposite direction. So our M values, okay, will still remain the same. Or rather not say M value, our K values will still remain the same. You understand what I'm saying? Okay? Because the underlying concept of parallel, okay, is this. So it didn't really matter whether you change the direction or not. Okay? Unless, okay, the direction will matter if the question in fact says that CD is equals to BA. Or CD is a scalar multiple of BA. Actually, yeah, if CD is equals to BA, then you must take care of the direction of how BA is like. But of course, there will not be any scalar multiple. You understand? Okay, because CD cannot be equals to AB. Okay? When two equal vectors, the direction must be the same, the magnitude must be the same. Okay? Yeah.
That means in this case we should put negative M or just M also.
Yes. Okay? So both will give you the same answer. Although the M values will be different. You understand? That's because of the concept of parallel. Okay? We'll end here today. Right? Next week, Monday, we'll continue with this. Unless I am able to finish marking your test, then I'll go to the test. Okay? So please remember to submit your PRWC.
Oh, yeah, you do that.
Yes, due today.